Okay, Assalamualaikum warahmatullahi wabarakatuh. Okay, my name is Muhammad Aimanul bin Wakidin and my partner is Tinagaran Tanggavellu. We going to teach you all about Harvard architecture. Do you know about Harvard architecture? So in this video, we will introduce about Harvard architecture. In Harvard architecture, there is five important part which is will control the process of the architecture. Okay, first is control unit, second ALU, third is instruction memory, fourth is IO, and the last is data memory. Okay, then I will explain about the info regarding Harvard architecture. Okay, the first one, a computer architecture will physically separate storage and signal pathway for instruction and data. The second, the term originated from the Harvard Mark I relay-based computer will store instruction on patch tape 24-bit wide and data in electromechanical counter.
Okay, the mentioned Howard Mark I device before we mentioned it. Okay, it is a IBM Automatic Sequence Control Calculator AICC. It is the largest electromechanical calculator ever built and the first automatic digital calculator in the United States. There is no need to make the two memories share characteristic. In particular, the word width timing implementation technology and memory address structure can differ. In some systems, instruction can be stored in read-only memory, while data memory generally requires read-write memory. In some systems, there is much more instruction memory than data memory, so instruction addresses are wider than data addresses. As for speed, in Howard architecture, the speed of the CPU has grown many times in comparison to the access speed of the main memory. For instance, every instruction run in the CPU requires an access to the memory. The computer gains nothing for increased CPU speed, a problem referred to as being memory bound. However, it is possible to make extremely fast memory, but this is only practical for small amounts of memory for cost, power, and signal routing reasons. The solution is to provide a small amount of very fast memory, known as CPU cache, which holds recently accessed data. As for the difference in internal and external design in Howard architecture, modern high-performance CPU chip designs incorporate aspects of both Howard and von Neumann architecture. In particular, the modified Howard architecture is very common. CPU cache memory is divided into an instruction cache and a data cache. Howard architecture is used as the CPU access the cache. As for the modern users of Howard architecture, principal advantage of the pure Howard architecture is that simultaneous access to more than one memory system has been reduced by modified Howard processors using modern CPU cache systems. Shown here is the one of the example that have multiple parallel data buses. As for the examples of microcontroller, we have AVR by Ed Malcorp, PIC by Microchip Technology, ARM Cortex M3 processor, which all uses Howard architecture.
Created using Powtoon.